Okay, this next video is still chapter 22, honors chemistry, and we're balancing redox and acid. So, first of all, you want to get the rules for balancing redox and acid, and here's the rules. Go ahead and take a minute and copy them down. Now that you've copied them, let me go through them. The first one says write the unbalanced equation breaking up soluble salts, strong acids, and bases. So this would be if the textbook gave you something like this, that you would break it up into that. That's really only going to happen in the homework problems once or twice. I already got rid of the ions that we don't care about. So don't worry about that for tests and quizzes, maybe in the homework once or twice. Then you're going to write the two half reactions. So you're going to have 10 turn into tin and chromium turn into another chromium. So 10 is going to turn into another tin compound, and then chromium can turn into the other chromium compound. Those are the two half reactions. It's unlikely tin is going to turn into chromium. That would just be ridiculous. So we just split them up so we can focus on them one at a time. Now we're going to balance the half reactions. First, we're going to balance the non-oxygen and hydrogen. So that would, in the first half reaction, that would be 10. There's 1 tin, 1 tin. Done. In the second half reaction, there's 2 chromiums. So I need to put a coefficient of 2 to make 2 chromiums on the right. Next, I'm going to balance the oxygens. So I might as well click off what I've done. Let's balance the oxygens. Now I'm in acid, so in acid I can use water to balance the oxygens. The oxygens are balanced in the first half reaction. So in the second half reaction, I need 7 oxygens on the right side. So I will add 7 waters. So the oxygens are balanced. Now I'm going to move on to hydrogen. Since I'm in acid, I could use H+ for the hydrogens. Hydrogens are balanced in the first half reaction. In the second half reaction, I have 14 hydrogens on the product side. Therefore, I need to add 14 hydrogens on the reactant side. And now I'm done with this part. Now number 4 is probably the hardest. You're going to balance the charges using electrons. Remember, electrons are negatively charged. So if I have 10 plus 2 has to equal 10 plus 4. And I can only use electrons. Then I'm going to add 2 electrons to the right. Plus 2 equals plus 4 minus 2. That is a true statement. Now on this one, a little rougher. The product side is plus 6, has to equal plus 14 minus 2. So plus 6 has to equal plus 12, which means I'm going to have to put 6 electrons over here. Okay? Now I scooch on. I'm going to multiply so the number of electrons will cancel. So I look up above and I see I have 6 electrons on the reactant side and 2 electrons on the product side. So I'm going to multiply the top equation by 3 and quite literally just go through and multiply all the coefficients by 3. Then I'm going to go on and add the half reactions, kind of like Hess's law. Remember that? Kind of like that. So we're going to cross out our electrons. 6 on the reactant, 6 on the product will cancel. Then I'm going to just add my stuff up. I've got 14 hydrogens left over, a dichromate, 3 tins, which yields 3 tin 4s, 2 chromium 3s, and 7 waters. Now, just like in algebra, you can check your answer. So I check 14 hydrogens, 2 chromiums, 7 oxygens, 7 oxygens, 3 tins, and the charges are 14 positive, minus 2, plus 6 is positive 18, positive 12, plus 6 is positive 18. So everything checks out, it's good. Let's try another one. We'll do 2 more of these. Same rules, just so we can refer to them. And we're going to balance an acid again. So we're going to write the unbalanced equation, breaking up soluble salts, strong acids and bases. It's already done. Check done. That's more of an AP thing. Then we're going to write the 2 half reactions. I'm going to have my sulfur turn into sulfur. And then I will have my nitrogen turn into nitrogen. So that makes sense. Now I will balance the non-oxygen hydrogens. I have 1 sulfur, 1 sulfur, 1 nitrogen, 1 nitrogen. That was easy. Now I will balance my oxygens. I'm an acid, so I can use water. I have 2 oxygens, so I will add 2 waters. I have 3 oxygens and 2 oxygens, so I'm going to add 1 additional water. Next, I'm going to balance my hydrogens using H because I'm an acid. I have 4 hydrogens, so I will add 4 hydrogen ions. I have 2 hydrogens, so I will add 2 hydrogen ions. So now, here comes the hard part. We're going to use electrons and balance the charges. Minus 2 has to equal positive 4. So it's actually going to take 6 electrons to get it all the way down to minus 2. Positive 2 minus 1 is positive 1, has to equal 0. Oh, so that's just 1 little electron. No big deal. So now I'm going to multiply my equations so I can cancel the number of electrons. Done there, about to be done there. 1 electron, 6 electrons both go into 6. So I'm going to multiply just the second equation by 6. So I have 6, 12, 6, 6, and I dare say again 6. And there we go. Now I'm going to add my half reactions. I'm going to cross out anything that's the same on both sides. So I'm looking, I've got 6 electrons, 6 electrons. Ooh, this will reduce. I've got 12 hydrogens and 14. So let me take 4 away. Now I'm down to 8. It's getting a little messy. Oh, waters. I have 2 waters and 6. So I'm going to remove 2 from both sides. And now I have to pull it together. So 8 hydrogens, 6 nitrates, a sulfide, a sulfur dioxide, nitrogen dioxide, and 4 waters. I'm going to double check because I can. 8 hydrogens, 6 nitrogens, 6 nitrogens, 18 oxygens, 12 plus 4 is 16, 17, 18, and 1 sulfur. Double check the charges. 8 minus 6 is 2, minus 2 is 0, equals 0. It works. Let's try one more in acid. So we're going to do the same rules. First one, only in your homework. 2 half reactions. Remember, if you feel comfortable, pause and do this yourself, and you can fast forward to the end and see if you got the right answers. So I just did my 2 half reactions. Now I'm going to balance the non-oxygen and hydrogen. So I need 2 iodines on both sides, and I have 2 nitrogens. So that's done. I'm going to use water to balance my O's. I have 3, I have 1, I need 2 more. And that's done. Now I'm going to balance my hydrogens using H because I'm an acid. Hydrogens are done. 4 hydrogens. 4 hydrogens. Good. Done. Now comes the challenge. We're going to use electrons. -2 equals 0. Only if I add 2 electrons. +4 minus 1, so +3 equals 0. So it does need 3 electrons over there. So I've got a 3 and a 2, which means I'm going to multiply the top one by 3 and the bottom one by 2, because they both go into 6 nicely. So this turns into a 6, and a 3, and a 6. And this one turns into a 6, and an 8, and a 2, and a 2, and a 4. And we did that so the electrons cancel. Now I'm going to add the half reactions. Okay, 6's go away. I'm looking for anything else that simplifies. I don't see it, so I'm just going to rewrite my equation with what's left over. Now you're going to ask, does it matter what order you write the reactants in? No, just as long as they're on the correct side of the arrow. And I'm going to double check. 8 hydrogens, 8 hydrogens, 2 nitrogens, 2 nitrogens, 6 oxygens, 1, 2 plus 4 is 6, 6 iodines, 6 iodines. 8 plus minus 2 is 6 plus, minus 6 is 0, which equals 0, check done. And that's how you balance an acid.